So thanks, Ginny. So hi, everyone, and thanks for joining us for today's session on preventing statistical errors before publication with Dr. Michèle Nuijten and Dr. Tom Hardwicke. I'm Jen Beaudry. I am the current president of AIMOS, the Association for Interdisciplinary Meta-Research and Open Science, and I'm also a member of the steering group for AUSRN, the Australian Reproducibility Network. And my day job is leading the researcher training, development, and communication team here at Flinders University in Adelaide. So before we begin, I'd like to acknowledge that I'm joining this meeting from the lands of the Kaurna people, but of course we have people joining us from other traditional lands as well. So I extend my respects to these nations' elders, past, present, and emerging. And so, as I mentioned, today we have two speakers, Dr. Michèle Nuijten. She will talk about different tools that you can use to find, correct, and avoid statistical errors in your papers. And we have Dr. Tom Hardwicke, who will speak about reducing statistical errors at psychological sciences and the initiatives that they've put in place over the last little while. For today's session, each of our speakers will have about 20 minutes, and then we'll address questions at the end. So if you have any questions, feel free to put them in the chat, but we'll probably only get to them at the end of the session. Before I hand over to Michèle, I just wanted to briefly tell you about AIMOS, in case you're not familiar with it, and then Ginny Barber will tell us about AUSRN as well. So the purpose of AIMOS is to bring together researchers who are committed to making the research process more trustworthy and more efficient, as well as to promote the study of how research is done and how it can be improved. We are an interdisciplinary society, and we welcome the views of researchers from all fields and disciplines. And we're also an international society with members from all around the globe. But we're focusing our efforts on building this community in the Australasian region so that we don't have to travel to North America or the Northern Hemisphere to connect with our like-minded colleagues. So we really want to build that critical mass down south. After the speakers, I'll give you a little information about our conference, the AIMOS conference that we're holding here in Sydney in November. But I'll hand over to Ginny now to tell you a little bit about AUSRN.
Fantastic, thanks, Jen. So I'm Ginny Barber. I'm another of the steering group of AUSRN. There's a number of us from across Australia. So Fiona Fidler, Tammy Hoffman, Shinichi Nagawa from who's in Canada, Alex Holcomb, Matthew Page, Louise and Ben Moll, as well as Jen. So we're a peer-led consortium and we are working towards improving reproducibility across Australia. We're part of an international group of reproducibility networks, the most active of which is in the UK, and that's where the kind of the model came from. And there is a move now to get an actual international consortium of these networks. It's very active globally, and the most recent networks to join were one from Canada and astonishingly one from Ukraine. So just to say this is a truly global network and we work closely with AIMOS. So thanks very much.
Great. Thanks, Ginny. So Dr. Michèle Nuijten is an assistant professor at the Meta Research Center at Tilburg University, where she studies reproducibility and replicability in psychology. She obtained her PhD in methodology and statistics at Tilburg University in 2018, and she's received an innovation grant from the Dutch Research Council to develop an efficient protocol to assess and improve robustness of psychological findings. As part of her research, she co-developed this free tool called Statcheck that she'll talk about later, which is basically a spell checker for statistics. Michèle serves on the editorial boards of several psychology and meta-science journals, and she's on the advisory boards of several initiatives related to improving robustness in psychology and other scientific fields, such as the Institute for Replication, the Error Program, and the Dutch Reproducibility Network. So I will hand over to Michèle now.
Thanks very much. Let me get my slides. There we go. Yes, here we are.
Great.
Yeah, thank you for having me. I'm very excited to talk about avoiding statistical errors. It's been something I've been thinking about quite a lot. And I've actually been thinking quite a lot about preventing a very specific type of statistical error, which is one that I will talk about right now. I will try to also venture into some related errors, but there's one particular one of interest to me. Let me show you one. This is a snippet from a published psychology article. I'll read it with you. Simple effects analyses within each of the two levels of valence were conducted, revealing a significant main effect of subtype upon the proportion of positive words falsely recalled. It doesn't really matter what the subject of this paper is about. The most interesting part to me follows now in the highlighted bit. We've all seen these, especially if you have a background in psychology, where we tend to back up claims with statistics like these. And I don't know how good your statistical intuition is, but there's something wrong with these numbers. And it's really hard to spot. But the nice thing about tests like this, so null hypothesis significance test, is that if you take the degrees of freedom and the test statistic, you are able to recalculate the p-value. These numbers, they belong together, they're a set. So effectively, it says something, or it should say something like 2 plus 3 equals 5. These numbers belong together. But if I now recalculate it, I see that the p-value is actually 0.06 and not 0.05. Let me show you a little bit more of an obvious example. This is another snippet from a published article. And here, maybe if you have some experience with statistical hypothesis tests, if you see these numbers highlighted, you can maybe already see that something is off here. Like you maybe have some intuition that an F value of 0.41 is very unlikely to go together with a p-value as small as this. And indeed, if I would recalculate the p-value based on the other information in this sentence, it would actually be hidden by my Zoom menu. It would be p is 0.52. So very, very different. This is not just a nitpicking exercise. This is something that happens very often. So in a kind of a line of research, so often more over and over, we find this these prevalences is that about half of published psychology papers that report these kind of statistics contain at least one of these inconsistencies, where the test statistic, the degrees of freedom, and the p-value don't match. Oh, this is walking from itself. In 12.5% of the cases, so say 1 in 8 papers, they contain at least one decision inconsistency, as we call it, around p is 0.05. So that means that the recalculated p-value falls on the other side of this 0.05 cutoff that we're used to using in psychology as the boundary for when we call something statistically significant. So this happens often. Why is this a problem? I mean, of course, sure, this is incorrect, but is this really a problem, or is this one of these annoying theoretical things that methodologists and statisticians like me just get really hung up about? I would like to argue that this is a very real problem, because inconsistencies like this can make results uninterpretable. These are a problem for what we call reproducibility, which means that we would not be able to go to sort of retrace the reported result back to the raw data. Normally, you would have to do a full reanalysis of the original data to see if you can find the same numbers. But if you find numbers that are internally inconsistent, you already know that this could never have followed from the underlying data. And this is a problem because that means that I don't know what the statistical result actually means. Another problem is that I can't use inconsistent statistics to, calculate effect sizes. If you want to do a meta-analysis, sometimes you have to recalculate some effect sizes. You can't use this information for that. Also, it could be a symptom of underlying problems. Like this is something we can spot. What else is going on? Before I give you the impression that a lot of this is all a malicious intent or so, let's sort of take a step back and think about how could these end up in your paper. Well, if you've ever worked with statistical software and you had to copy some numbers into your manuscript, I'm sure that you've run into the situation where you had pages and pages of statistical output, and you would have to, like in these very tiny fonts, figure out which numbers belong together, and then you accidentally copy something diagonally or you mistype something. So it's very easy to make mistakes like this. It's also something that I'm assuming no one really wants. So no one wants to have mistakes in their paper. And journals also don't want mistakes. Readers don't want these mistakes. But apparently they keep showing up. So we need something to avoid them. And this is where Statcheck comes in. So Statcheck is a tool that I developed together with my colleague Sascha Epskamp quite a while ago already. And it is a spell checker for statistics, if you wish. It is based on an R package. Sorry, I don't know why this is running from itself. It's a spell checker for statistics in R. We also have a Shiny app to make it a little bit more user-friendly. So what does Statcheck do? Statcheck automatically tries to find statistical results in a paper. It tries to recognize what the test type is, what the degrees of freedom are, the test value and the p-value, and then it uses this information to recalculate the p-value. One thing to note here is that if these three numbers belong together, if you want to check if they are consistent, you have to pick one of these numbers to recalculate. We picked the p-value. I could have also said, you know what, with this information, I'm going to use the degrees of freedom and the p-value to recalculate the test statistic. Like it doesn't really matter which of these two numbers you pick to calculate a third, but this is the way that we did it. And you can get to the conclusion that, well, if you recalculate this, Statcheck will tell you that this particular result is consistent. But what if this was the result? Maybe you wrote down 0.046 for the p-value, and then Statcheck will tell you, oops, this is an inconsistency. You wrote down that your p-value is 0.046, but actually it's 0.036. Or at least that will be the p-value belonging to these other numbers that you reported. Another scenario could be that you wrote down p is 0.063. So here, what likely would have happened is that these numbers were switched. Here, Statcheck will tell you that you've made a decision inconsistency. So that means that the reported p-value is larger than 0.05, but the recomputed one is smaller. So in your reported result, it seems like it's not significant, whereas if you recalculate it, it would be. This could also happen the other way around. There's a couple of things to keep in mind when using Statcheck about its accuracy. Statcheck is specifically designed to find statistics that are reported in APA style. So this is a reporting style mainly used in psychology. And the nice thing about this is that it's extremely specific in how it prescribes to report these statistics. So it really says the exact order in which these letters and numbers and parentheses, etc., should appear. And that's how Statcheck is able to find them. That also means that if there's a different reporting style used, that Statcheck probably won't pick it up. For the statistics Statcheck picks up, it has a very high accuracy in classifying them in inconsistency or not. We compared this by looking at a manual check versus Statcheck, and the sensitivity and the specificity, so the true positive rate and the true negative rate, are very high depending on some settings. You can tweak a couple of things in how strict you want to be with certain, like do you want to count p equals 0 as incorrect? Which I think we should, because it is impossible to get a p-value of exactly 0, but some people think that's too strict, so that's something you can tweak. It's important to note that Statcheck is not fraud detection software or something. Like, it is really a spell checker. That's the best comparison I can make. And it is also important to realize that sometimes it can make mistakes. So double checking is always a good idea. What can you use Statcheck for? In general, well, you can use it for whatever you want. It's open source software, so, go crazy. But the three main uses that I see are self-checks, peer review, and research. And for the goal of this talk, I'll mainly focus on the self-checks. So what can you do as an author to avoid errors? The easiest way to go about this is to go to the web app at statcheck.io, where you can simply upload a paper, and there's literally one button that you need to click. So I hope that helps with the user friendliness. You upload a paper and it tries and finds the statistics for you. So you click on browse, you upload your document in a PDF, HTML, or docs format, and it will give you back a table like this, where it lists the statistics it found. There are some things that we can tweak. So this is about the double checking. Here you can see that one reported t-test is flagged as an inconsistency. But if I go to the actual text in my manuscript, I see that this is a test that I performed one-tailed. So this test was one-tailed, and then the result, and then another one that's not. If you do a one-tailed test, you divide your p-value by 2. But Statcheck does not expect that. Statcheck expects two-tailed tests, so that's why it will flag it. But maybe you don't want to be so strict. So what you can do then is change the setting here where you say, try to identify and correct for one-tailed tests. You click that, and then your t-test will be counted as consistent, because Statcheck will understand, like, oh, wait, if I would divide my recalculated p-value by 2, I am fine. This is also a website that has all the resources related to Statcheck in one place. So there's a frequently asked questions about which results Statcheck detects, how it deals with certain edge cases. There's a manual. You can go to the cron page where the actual R code can also be found. So the R package, I've skipped over that now, but it has more, you can tweak more things if you use the R package compared to the web app, but the functionality is effectively the same. There's some background papers and some meta research we did with this, and you can go to the GitHub page where you can find the actual code that is in development. So take a look if you're interested. And I also said I would talk about other tools to find, correct, and avoid statistical errors. And this is something I've been thinking quite a lot about lately. And I thought that this talk would be a fantastic occasion to list like all the cool tools that are out there to find, correct, and avoid statistical errors. And then it turns out there is not that many. There's all kinds of things you can calculate based on a paper. You can spot all kinds of things. Like, this is sometimes also called like forensic meta science, which I think is a very cool name. But trying to spot errors in papers is one thing, but to have a tool to do it is quite tricky. So one thing that came close, or yeah, the point I also wanted to make is like these Statcheck type errors are of course only one very specific type of error that can occur, and the type of error that we could easily automatically check. But I'm sure that you can imagine all the other things that could go wrong when copying numbers into your manuscript. A tool that comes closest to an automated statistics checking tool is a tool to find a type of statistical error, and it's called GRIM. That stands for Granularity Related Inconsistency of Means. It's from James Brown and from Nick Brown and James Heathers. And what this test does is it checks if reported means are even possible. So then example is 3 first-year students, mean age 21.5, participated in the study. I explicitly or intentionally use a very small sample size here of only 3 psychology students, because then the intuition is maybe easiest to grasp. If you have a sample size of 3 and you have age that is reported in whole years by them, it is not possible to get a mean that ends in 0.5. If you have 3 people, means should end in 0, 0.33, or 0.67. So you can immediately see that this is impossible. And Grimm kind of extends this logic to larger sample sizes, I think up to 100, but I think there's an extension out there now for larger sample sizes too. And it will help you check if there's any of these impossible means. One thing to note is that it's semi-automated, so it will not read the text for you. And the reason is, which I can tell from experience, because this is really hard to automatically read text and extract the correct information. But it's semi-automated in the sense that you can easily calculate this with a macro. And I think that there is a web app and an R package for this now too. So this is also a cool thing to check out. There's also really fun blogs about this. James Heathers has a very nice writing style I can highly recommend. Other tools to find statistical errors. Yeah, the kind of the elephant in the room, maybe, like what could be the role of Gen AI? Like all these large language models that are floating around now, everyone is trying to figure out like what can we use it for? Maybe if we give it a prompt like act as a statistics expert, extract all statistical tests and list all instances where a set of numbers is internally inconsistent. You know, something like this. But the answer now is that we don't really know how well this works and what the pitfalls could be technically, but also more ethically or in usage. So this is kind of uncharted territory, which I find interesting to see what this could potentially bring us. We'll see. To be continued, I guess. There's also tools to avoid statistical errors in the first place. I mean, that would be the dream, I guess, if you want to think about it like that. I think a very, very large reason for why this goes wrong is because of the manual transfer of output from your statistical software to your manuscript. So the copy and pasting part. There are ways to just avoid this copy and pasting altogether if you use reproducible reporting, which is also called literate programming. I'm not entirely sure if this is exactly the same, but the idea is that you embed code in your manuscript and that you update the results automatically. So that the analyses are run within the manuscript, which is really cool. Some known tools for this are Markdown and knitr in R, and I think they're successor now is called Quarto. This is all based, I think, on working with R, but I think Quarto also uses other programming languages. If you use this, then there is no chance that you will accidentally report an incorrect p-value in the sense that, you could still do the incorrect analysis, but there will be no cases anymore where you report impossible p-values because these will be automatically generated based on the entire test. So this is definitely useful. There's also just some general good ideas to think about. They're not really tool related, but they will help a lot in thinking about avoiding statistical errors. One advice I can give is run in-house reproducibility checks and code verification. I guess that this is kind of a weird thing that we have in science where very often everything is checked within a manuscript, especially in a PhD supervision situation. Your supervisor will be like ad nauseum checking your manuscript, changing commas, complaining about the certain reasoning things, all these things. But the underlying code, sometimes only one person has looked at that at all. Whereas that is where a lot of the research actually happens. So checking that and making sure that this is correct is a very good idea. Another general good idea is to share data and code, and specifically share fair data and code. We are now at in a situation where more and more people start sharing data and code, but we find out now that if data and code are not well documented, well structured, then it's really hard to actually do something with it. And there's one other general good idea, submit to a journal that cares about these things. And someone told me that someone after me will talk about just this. I will wrap up this talk. I just want to repeat some of the take-home messages that statistical typos are very easily made. This is an obvious problem or an easy problem to make. Even though they seem kind of maybe benign or like a stupid problem, they do really affect trustworthiness of results. So it's really worth looking into how we can get rid of these. And there are tools to quickly spot them or maybe avoid them altogether. And we should all share data and code. And maybe we should all look into what psych science is doing. Let's hear from Tom. Thanks very much.
Thanks so much, Michèle. That was really interesting. So again, if you have questions for Michèle, just pop them in the chat and we'll get to them at the end. So now we'll hand over to Tom. So Dr. Tom Hardwicke is a senior lecturer in the School of Psychology at the University of Sydney. And he is the senior editor for Statistics, Transparency, and Rigor at the Journal of Psychological Science, as Michèle pointed to. He works at the intersection of psychology and meta-research on projects related to transparency, bias, peer review, scientific criticism, and reproducibility. Prior to joining the University of Sydney in 2025, he was a senior research fellow at the University of Melbourne, and before that, he completed postdoctoral fellowships in Berlin, Amsterdam, and the US of A. He received his PhD in experimental psychology from the University College London in 2016. So I'll hand over to Tom now.
All right, thanks very much. Thanks for that extremely smooth handover, Michèle. That was great. Okay, yeah, so for the last, I guess, 10 years or so, I've been doing meta research or research on transparency and various kinds of issues and various kinds of errors in psychology. And one quite unsatisfying element of that work is that you're often trying to close the stable door after the horse has bolted. So the errors are already out there in the wild, they've already done some damage. And then there also seems to be a general reluctance to fix things after they've entered the scientific record. About a year and a half ago, I had the opportunity to try doing things a little bit differently and started running a team at the Journal of Psychological Science that's dedicated to trying to catch errors and improve transparency before papers are published. So I'll just start my talk by briefly summarizing some relevant meta-research that we've been doing over the years, which suggests that there's plenty of problems out there to fix. And then I'll provide some detail about what we're doing at the journal to try and fix those problems before they enter the published literature. So let me start with transparency, because transparency facilitates the detection of statistical errors. So for example, if you have access to the raw data and the analysis scripts, then you can rerun analyses, you can check coding errors. And if you have access to a pre-registration, for example, that helps you to properly judge the risk of bias from data-dependent decision-making and selective reporting. So transparency is like the raw ingredient that you often need for detecting a lot of types of statistical errors. And we've had almost 15 years of concerted effort now in psychology of trying to increase transparency across the field. And my colleagues and I have been running studies to assess how successful those collective efforts have been. So in these studies, basically what we do is take a random sample of empirical psychology articles, and then we manually check whether they followed various transparent research practices like data sharing and pre-registration. And this enables us to estimate the prevalence of those practices across the field of psychology with a certain degree of precision. So the overall picture is this. Basically, between around 2015 and 2022, there has been some modest increase in the uptake of transparent research practices in psychology. They might be a bit more common in more prominent journals. So, for example, the proportion of articles sharing empirical data increased from around 1.6% in 2015 to about 14% in 2022. So there has been some modest improvement, but in absolute terms, that means adoption is still very far from routine, and we have quite a long way to go. There's also evidence from several lines of meta-research that there are various types of statistical errors scattered across the psychology literature. One of those studies is, of course, Michèle's line of work, but there's lots of other issues that come up as well, ranging from statistical mistakes, misuse of statistics, misreporting of statistics and sometimes misinterpretation of statistics as well. And one issue that I've been looking at in particular is computational reproducibility errors. So the ideal of computational reproducibility is that you should be able to repeat the original analyses on the original data and get the original results that's reported in the original paper. And if that process fails somehow, then arguably that's the most basic kind of statistical error of all, because we no longer know where the numbers have come from. So in a couple of studies now, we've tested the computational reproducibility of published articles, firstly for 35 articles that were published in the journal Cognition, and then in a later study we did this for 25 articles that were published in Psychological Science. And we looked at articles that had already shared their data and they'd already passed some initial quality checks. So this is a small subset of the much broader population of psychology articles, which, as you'll remember from that previous slide, most of which aren't sharing their data at all. So if anything, the results of these reproducibility checks are going to skew towards more success relative to the larger population of psychology research. So how did these reproducibility checks go? If you've ever tried putting together flat pack furniture, I would say that's an excellent analogy for our experience. We had really vague instructions, bits of pieces missing data sets, etc., missing code. And we ended up spending hours and hours on something that you think should take you, an hour at most. So it was an immensely frustrating experience. But more concerningly, we found that there was at least one non-reproducible value in at least in 40 of the papers that we examined. And most of the reproducibility issues were due to incomplete, unclear, or occasionally incorrect reporting of the analyses in the original papers. So the kind of important lesson from this, I think, is that transparency alone is not enough. It's one thing to share your data set, but we really need the data to be clearly documented, and we need the entire analysis pipeline from the data to the results reported in the final manuscript to be clearly documented as well. On a personal note, after finishing these projects, I swore that I would never again do a reproducibility check. And later on in this talk, you'll discover that I was lying to myself at that time. So what can we do about this lack of transparency and these statistical errors? And of course, there's no single silver bullet solution to a complex issue like this. But I'm particularly interested in what journals can do, because I think they're well positioned to influence research practices. So we know that journals can have a bad influence, like when they're not publishing null results, for example. But I also think there's a lot of potential to use that power for good as well. And we actually have some evidence about how effective journal policies can be. So these are the results of an interrupted time series analysis that we ran to evaluate the effectiveness of a mandatory data sharing policy that had been introduced at the journal Cognition in 2015, and that's shown by the black vertical arrow on the graph. So as you can see, there's this slowly increasing trend towards data sharing even before the policy was introduced. But then after the policy is introduced, there's this substantial increase in the proportion of articles that were sharing data, and that approached 100% of articles by the end of the year of this particular assessment period. Now, importantly, the policy did have some limitations. So when authors said the data is available, we actually checked if the data was available, and we also checked to see if the data sets would be, in principle, reusable by another scientist. So specifically, we tried to access the data, we looked to see if all of the data had been shared, and we checked to see if the data were clearly documented. And we found that most of the data that was being shared in the pre-policy period was unlikely to be independently reusable. And this had improved somewhat in the post-policy period, but still around a third of the data sets didn't seem to be independently reusable according to our criteria. So it seems that this policy was effective at increasing data sharing, but some additional work needed to be done to help improve the reusability of the data sets. So you might be thinking, okay, great, we've identified a evidence-based intervention that appears to increase transparency. Surely lots of journals have adopted this as well, but alas, when we examined the transparency policies of a random sample of psychology journals a few years ago, we found that most did not have any policies related to sharing data or analysis scripts, and very few of them, only 5%, had a strict policy like cognitions that required sharing of data. So that brings me up to January 2024, when Samin Vazir was appointed as the editor-in-chief of Psychological Science. So this is a very influential journal in our field. So it was a very pleasant surprise when Samin was appointed editor-in-chief. And Samin asked me if I would set up a team at the journal to help improve statistics, transparency, and rigor. So I'll tell you a little bit about what we've been doing. Firstly, for context, before we started working at the journal had actually already done quite a lot of work to try and improve transparency. So for a long time, it had been offering badges to authors, putting these badges on their articles if they voluntarily shared data and materials or they pre-registered their studies. And more recently, the journal had started requiring authors to submit data during peer review, but it didn't require sharing after peer review. So on the screen here is the results of an early study of the badges scheme, which found that before badges were introduced, less than 3% of psychology articles were reporting open data. And in that post-policy period, around 23% were reporting open data, and that trend accelerated and approached 39% by the end of that assessment period. That's the first half of 2015. A more recent update is that in 2022, 69% of articles published in Psychological Science had an open data badge, 55% had an open materials badge, and 43% had a pre-registration badge. So this is obviously a lot better than those prevalence estimates for the field more broadly. And you can see that at the bottom of the graph, the gray lines there represent some comparison journals that didn't have any data sharing policies at all. But I think there's still a lot more we can do here to get those numbers higher. And of course, these numbers don't speak to the actual quality of those data sets and materials that are being shared, etc. So one of the major policy changes that we've made at the journal is to make transparency the default expectation. So that means that now for all empirical articles, we expect that all raw or primary data, all of the research materials and all analysis scripts must be made publicly available in a trusted third-party repository like Zenodo or Open Science Framework, unless there are some reasonable constraints like ethical or legal issues. And I'll talk more about what I mean by reasonable constraints in a moment. A key reason for focusing so much on transparency is that we recognize that whatever we do at the journal and whatever kind of peer review process we have, we're not going to catch every error. So we want to make sure that all of the raw ingredients are in place before that paper is published, so that the broader scientific community can then critically evaluate those papers after they're published as well. Another thing that we did was to drop the badges scheme. So badges are a little bit controversial in the world of open science. Some people love them and think they're great. Some people think they're a bit silly. In terms of evidence, it's quite limited, and the outcomes of studies have been quite mixed. But we decided to stop the badges scheme, and our basic motivation was that now we're requiring data and materials as a default expectation. The vast majority of studies would be getting these badges anyway, so they're not really a useful signal anymore. With pre-registration, it's a little bit more complicated. We don't require pre-registration. We just require that authors say which aspects of their research were pre-registered and which were not pre-registered. But there's evidence showing that many articles that have received the pre-registration badge don't really have high quality pre-registrations. The extent to which a given pre-registration can constrain researcher degrees of freedom can vary enormously from one study to another. So a binary badge that just says pre-registered or not can often fail to capture that level of nuance and potentially mislead people more than it can inform. So for those reasons, we also dropped the pre-registration badge. So instead of badges, we now have this research transparency statement. So every empirical article must have this statement, and it must contain disclosures about all of those items that you can see in bold on the screen there. And the research transparency statement appears at the end of the introduction section and right before the methods section. And most of the disclosure statements have a kind of standardized language that we require authors to use unless there's some reasonable reason to deviate from it. And that means that we try to make them be explicit, that they are, in fact, following the journal's policies. They are making all primary data available, for example. And it also means that we require a kind of deeper level of nuance. For example, with pre-registration, authors can't just say the study was pre-registered. They need to say whether the aims, methods, and analysis plan were pre-registered or not pre-registered, and also say whether there were deviations or not from the pre-registration. So we require a little bit more detail than would normally happen with a badge, for example. Now, I mentioned reasonable constraints. So we completely recognize that although there is this scientific priority for transparency that has to be balanced with other ethical, legal, and occasionally practical constraints. So we do allow transparency exemptions in some cases, and we consider those currently on a case-by-case basis. At a minimum, if a particular paper can't share data, for example, that needs to be explicitly stated in the research transparency statement, along with a reason that explains why, so the broader scientific community can also judge whether they think that is reasonable or not. In general, when we're making these decisions about exemptions, we're guided by the maxim that research should be as open as possible and as closed as necessary. And that means that sometimes we will try to find a middle ground. So, for example, if the authors say, we can't share the data because there's sensitive information in there, and we look at that and we say, okay, we agree, like it doesn't look like the data can be anonymized. We might ask if it's possible for them to share the data at least with our internal team, so that at least there has been some third-party eyes on the data and some kind of checking and verification of the data, even if in that particular circumstance it can't be made publicly available for reasonable reasons. So we have this new set of policies, but I think it would be pretty naive of us to assume that they're always going to be followed. And we saw in that cognition study that policies can start to break down a bit if there's not much oversight. So we've created this team of editors, volunteer editors at the journal, who are dedicated to improving statistics, transparency, and rigor. So we're called the STAR team. Ethics is also in our remit, but then the acronym would have been STARE, so we leave that one out. And here's the rest of the team. And you might think, calling yourself the STAR team sounds pretty arrogant. But we did ask ChatGPT for some ideas before we came up with this acronym, and it suggested quantitative vigilantes, integrity sentinels, and guardians of rigor. So it could have been a lot worse. So we'll settle with STAR team. What do we do exactly? Although it looks like we have this very large team, psychological science gets a lot of submissions. So we have to use this resource wisely across the publication pipeline. And, people are volunteering their time as well. So this is how it works. Our checks only start when manuscripts go out for an external peer review. So manuscripts that are desk rejected don't get seen by the STAR team at all. Our light check that we run during external peer review takes roughly 30 minutes. And the goal is to capture any kind of major problems with the manuscript. We detect if, for example, the authors haven't shared their data at that point, are all the links working, etc. But we don't really dive deeply into the files and start checking that, everything has been shared, etc. Next, if a manuscript passes the initial peer review stages and the handling editor thinks that it has a good chance of publication, we try to ensure that it gets a thorough statistical and methodological review from a STAR editor, if possible. A key thing we want to look at here is whether the study has been pre-registered or not. We want to do an assessment of the risk of bias from data-dependent analyses, as well as other statistical issues. This is something that we've started to prioritize a bit more fairly recently, and we don't always have the capacity to do this for every single manuscript at this stage. Finally, once a manuscript has got through all of those stages, it reaches what we call the conditional acceptance stage. So it's pretty much accepted as long as it passes some final checks by the STAR team. So we do what's called the deep check. That means we dig into the files, we check if they're clearly documented, if all the relevant research materials have been shared, for example. And we also run a reproducibility check. And recently we've set up a new network of volunteers called the Repeat Network, who are helping us do these reproducibility checks. And that's taken a lot of load off the STAR team, and the STAR team is now starting to prioritize those statistical and methodological reviews. Okay. So here are some numbers as well. This is since we started in January 2024. As you can see, we get a lot of submissions. A lot of those are desk rejected. We've run about 400 light checks so far. We're not currently keeping track of how many statistical methodological reviews we do. And we've had about 70-ish manuscripts that have passed through or are currently at the deep check reproducibility check stage. And we are keeping track of the kind of issues that come up. I don't have any data for you right now in this presentation. But basically, every manuscript has some problems. I don't think I've seen a single perfect manuscript. But most of those problems are probably minor. We have caught some major issues. One case recently we had involved one of our STAR editors, Olmo van den Akker. He was running a reproducibility check, and during that check, it turned out that the authors had accidentally swapped the experimental conditions during the analysis, and that meant that the results were the opposite of what they had reported in their original paper. And when that error was discovered, they decided to withdraw the manuscript. Okay, so I'll wrap up in a moment. Just as a departing thought, I think it's quite difficult to know how many errors our team is kind of detecting and deterring. But we're not aiming for perfection. We're just trying to make things a bit less wrong. And it's admittedly quite hard to gauge whether the amount of effort and work that's going into doing these checks is worth it in terms of the amount of errors that we might be preventing from reaching the literature. And that could be an interesting point for us to discuss, the kind of resources that go into this kind of work. But I will just say that when that manuscript was withdrawn recently, that I just mentioned, we were discussing it in the STAR team, and one of our STAR editors, Julia Beitner, pointed out that, yeah, we put a lot of work into these checks, but imagine if just that single manuscript had been published. It would have been read by many people. It would have been cited by many researchers. Some researchers might have tried to build upon the findings and run their own studies. So imagine all of the hours and the money that could have been wasted following up on that particular manuscript if it had eventually seen the light of day. So that was at least reassuring in the short term that we are doing some useful work at least. So thank you so much for listening, and feel free to get in touch if you have any thoughts or feedback, and looking forward to having a bit of a discussion.
Excellent. Thanks so much, Tom. Do you want to just stop sharing your slides? Perfect. That way we can see more people. I'm happy to open up to the audience for any questions that they have. It's been really interesting to hear about what's going on for both of you in terms of working to prevent these statistical errors. Does anybody want to ask a question directly? I think you can all unmute yourself, although maybe... Jenny, can they unmute themselves?
Should be able to, yes.
Yeah. Owen, do you want to go ahead?
Hey, thank you so much. Thank you both, Michèle and Tom, for your great talks. It's really interesting. Tom, I'm interested in the workflow that you described for the deep reproducibility checking, whether there's any components at that stage of like forensic meta-science checking for like data integrity. I know that recently I've been involved in some data integrity cases as a data editor, where it's only post-publication after the fact that we're kind of chasing publications by a set of authors where we suspect that there's been cases of data manipulation. But I guess typically in the data editor process, it's not something that we would proactively look for. So I'm curious if there's any kind of automated or standardized checking for looking for kind of possible indications of data integrity or manipulation problems that are part of your processes, or if that's something you'd think about?
Yeah, that's a great question. Nothing systematic, I would say. Part of the problem is that there are so many tools out there, and many of them focus on particular kind of niche issues. It's not always clear which tool we should be running, on which paper. And often, you can't just run a particular tool on something. You kind of need to understand how that particular tool works. So we do have quite a lot of expertise in the STAR team and people who know these tools well. But one issue we have is, applying that kind of knowledge systematically to each paper and knowing when to deploy the knowledge in different ways. So it's something I'd like to work on more and think of ways to do that. Having some kind of decision tree maybe that helps us identify, these are the relevant tools that you can use on this particular paper. And I'd be interested to hear any thoughts about how we can do that better.
Great. Kylie?
Yeah, thanks for raising that topic. I guess it's a good opportunity to promote our IPD integrity tool. So our teams developed the individual participant data integrity tool, which we've got a sort of a version 1, but we are automating a lot of the processes to make it much more user-friendly, trying to, make it more accessible. So maybe we can talk more about if you could potentially incorporate any of those into your checks as well.
And Kylie, will you talk about that at the AIMOS conference?
I am submitting an abstract, so hopefully it gets accepted.
Hopefully it does. Excellent. Ginny, do you have a question?
Yeah, fantastic talks. Thanks very much. My day job's I'm the editor-in-chief at the Medical Journal of Australia, and we've been trying to move towards better transparency. One of the challenges we have is one particular area is we publish quite a lot of Indigenous health, and there it's really not possible to share the data. So we move towards having a statement about data availability. But so my question, I guess, actually, to Tom in particular, but I'd also be interested in Michèle, what's been the response of authors to this kind of analysis or scrutiny? Where do you find the best kind of uptake of what you're trying to do?
Yeah, good question. We've not had a lot of pushback or issues, to be honest. It could be that when your manuscript is under scrutiny at a journal, that you don't want to say what you really think, and maybe a lot of authors are kind of annoyed. That could well be true. But so far everything's gone pretty well. There have been a few hiccups with sometimes things take a little bit longer than you'd hope, and some pushback and people feeling a bit disgruntled because of that. But in general, it's difficult to say because I'm very biased, right? But I feel like it's gone very smoothly, and maybe having this kind of mandate at an influential journal has helped to shift the playing field a bit. So it used to be that, some people would be putting a lot of effort in because they thought these things were valuable, and some people just got away with not doing them. And this has leveled the playing field. It said, everyone now has to do this stuff. So perhaps everyone kind of knew that already, and we're already moving in that direction. And this just kind of ensures that it's kind of fair for everybody.
Yeah, maybe if I can follow up on that, I think it makes a huge difference for authors if they know beforehand, like before they submit, that this will be asked of them and that they have to put effort in it to be able to be accepted at such a flagship journal as Psych Science. I think the spillover effect is also maybe that if they get rejected at Psych Science, they've already prepared all these materials anyway, so you might as well just share them. But I think the counterpart, where if the journal doesn't immediately require data in such a structured way with actual checks, then what happens is that people state in their manuscript, and we've all seen this, data are available upon request. Spoiler alert, they are often not available upon request. They are often just plainly ignored. And this is extremely frustrating because then you do get the credits for sharing your data or being transparent or so, but it doesn't mean anything. So I think that the effort that Psych Science is putting in is extremely valuable and really should be an example to other journals in the field to not have these empty statements floating around anymore.
Excellent. Any other questions? Michèle, could you just tell me what types of tests are included in your Statcheck software?
Sure. So now I have to list. I think there's 7 by heart. So the standard t-tests, f-tests, correlation, chi-square, z-tests, and q-tests. So q-tests are very specific to meta-analysis, but all the other ones are quite standard psychology type tests, I guess. So Statcheck really aims for the low-hanging fruit in the simple analyses, but in practice, many of the analyses that we do in psychologies are correlational, are ANOVAs, and there the results are reported in a way that Statcheck can usually find.
Yeah, excellent. Well, thank you very much. And Owen shared in the chat, Michèle, for your reference, that his experience with asking AI to evaluate manuscripts hasn't been so successul. So
yeah, I totally echo that. I'm trying not to be too skeptic towards all the new tools because I don't want to be the grumpy person who is against all innovation, but I am the grumpy person who is against these types of innovation. But I'm curious to see how this will develop. So I'm keeping tabs on it to see how it will develop.
excellent. And then we've got one more question, and then I'll just wrap up by telling you about the AIMOS conference and some of the other initiatives taking place. So Brendan asks, Tom in particular, so many researchers in the Global South are not familiar with open science practices like data sharing, pre-registration, etc. And so would they be penalized for not doing so when submitting their papers to Psych Science?
No, in the sense that we don't, the STAR team doesn't, look at a paper that's not shared data and immediately say, this needs to be rejected. We work with authors to help them meet the requirements of the journal. So at that stage in the process, it is still possible to do a lot of the transparent research practices. You can start sharing your data, etc. And yeah, we do encounter authors with a range of different knowledge about how to do these things. Very experienced authors who are still struggling to use the open science framework, for example, because everybody does, or authors who've never really done these things before. So we try to be as helpful as possible. I hope we don't come across as a kind of, team that's kind of like trying to penalize people, but rather just trying to be helpful. One caveat to that is pre-registration, which obviously you can only do before you've started running your study, and then it's kind of a bit too late. So perhaps there needs to be more work on spreading knowledge about pre-registration to help with that. Yeah.
Excellent. That's good to hear that you work with the authors to meet that standard. So I'll just take one more minute of your day just to flag that our conference is coming up Wednesday the 19th of November to Friday the 21st at the University of Sydney. Registrations are open, as is our call for abstracts. And so our call closes on Monday, this coming Monday, September 1st at 11:55 Australian Eastern Standard Time. So if you're hoping to come to AIMOS and submit a proposal, then please don't miss that deadline. And then I just want to flag that we're trying to find out who the meta-researchers and meta-scientists are in Australia. And so if you're thinking, hey, that's me, then please complete this very brief survey to join our database of meta-researchers. And then we'll use this information to connect our community even further and share opportunities and resources. And finally, at Flinders, we've been lucky enough to have Ivan Oransky, the co-founder of Retraction Watch, agree to give a talk for us. So it will be a webinar on Wednesday, the 29th of October. And he's agreed to open it up to people from anywhere around the world. So If this aligns with your time zone and you'd like to join us, then please feel free to register via Eventbrite. And we hope to see you there for that. And that's it for us. So thank you very much, everyone. We will share the recording with you, and we'll also post it on the AIMOS website and the AusRN website as well, where you can catch up on previous sessions. So that's it for us. So thank you very much to Tom and Michèle, and for Ginny to helping organize as well. Enjoy the rest of your days.